Adding and subtracting rational expressions. Does everybody remember finding least common multiples? Least common multiples of just numbers. Like, for example, what's the least common multiple of 3 and 5?
15.
15. Okay, multiples are not the same thing as factors. 3 and 5, so the multiples of 3 would be what? 3, 6, 9, 12, 15, and so on. The multiples of 5 are 5, 10, 15, and so on. The least common of the two is 15. If you're ever unsure of how to get the least common multiple, you can start out by finding a common multiple by just multiplying the two numbers together. So in this problem up here, when there's a polynomial involved, then you need to factor both of them. So we're going to find the least common multiple of 4x squared minus 36 and 6x squared plus 36x plus 54. So I need to factor the first one right here. First thing you always do when you factor is take the GCF out, greatest common factor. What's the GCF of 4x squared minus 36? 4. Take 4 out, you're left with x squared minus 9. This falls into the difference of squares formula, so this factors to x plus 3, x minus 3. So 4x plus 3, x minus 3. That shouldn't be anything new. Over here, first thing I did was take a 6 out. X squared plus 6x plus 9. And this part right here, this trinomial factors to x plus 3, x plus 3. Or if you want, write it as x plus 3 squared. So everybody understands the factoring part, right? Now let's get the least common multiple. Start out by getting the least common multiple of 4 and 6.
24.
No, that's a common multiple, but not the least common multiple. The least common multiple of 4 and 6 is 12. Right? Everybody agree? Now, for the factors, the easiest way to think about it, any factor that's included in either one of them has to be part of your least common multiple. Since x minus 3 is involved in this one, it doesn't have to be involved in this one to be part of the least common multiple. Now x plus 3 is involved in this one and twice over here. And you just take the largest of the two. Since it's involved twice here, you put x plus 3 squared. That's how you get your least common multiple.
Wait,
Does that make sense?
He said
The
that
factor, for the factor part of the least common multiple, it does not have to be involved in both of them. Just one of them. That's why I put x minus 3 as part of my least common multiple. For the x plus 3, you have an x plus 3 here, you have an x plus 3 squared here. So you take the x plus 3 squared as part of your least common multiple. That's the rule that you need to remember in getting the least common multiple of the factors. The number part is easy. For the 4 and 6, it should be easy to get 12. Okay?
why didn't you say x plus 3 to the cube? Why did you say?
Because then you would be multiplying. I mean, that would be a common multiple if you put x plus 3 cubed, but it wouldn't be the least common multiple.
Oh,
All you need is 2 of them, because 2 is the most you have in this one. You have 2 over here, you have 1 over here. So you take the largest of them, which is the 2.
okay.
Alright, let's look at the next example.
Why do you put the x minus 3?
Because any factor that's involved in either one of them needs to be part of your least common multiple. Okay? And you'll see that over here when we add 2 of them together. Okay, simplify. Add those 2 together. 1 over x squared plus 5x plus 4 plus 5x over 3x plus 3. So the first thing you need to do is get them all in factored form. So I factored x squared plus 5x plus 4 to this. And I took a 3 out of here to get 3 times x plus 1. Okay? Question about how to get them to factored form. Then you need to figure out what the least common denominator is. In order to add fractions, you have to have a least common denominator. So we need to find the least common multiple of those two denominators. So you have an x plus 4 as a factor. That's got to be part of your least common multiple. You have an x plus 1 and an x plus 1. That has to be part of your least common multiple. And you have a 3. That has to be part of your least common multiple. So your least common denominator is 3, x plus 1, x plus 4. Got it? So you got to ask yourself, what are you missing over here from your least common multiple? You're missing the 3. So I have to multiply the top and bottom by 3. So I get 3 right here. Okay? What am I missing over here of my least common denominator? The x plus 4. So I have to multiply the top and bottom by x plus 4. So I end up with 3 plus 5x squared plus 20x right here in the numerator when you put both numerators together. Got it? And that simplifies. You need to put it in standard form. The 5x squared plus 20x plus 3, and all of that is divided by your least common denominator. All right, now be careful. You will be given some problems where this can be factored further. If it can be, go ahead and factor it, this numerator, because one of your factors might divide out with one of these factors. But in this case, this cannot be factored anymore. Okay? Question. All right, next one. Same type of problem, but it's subtraction. 7y over 5y squared minus 125 minus 4 over 3y plus 15. So again, factor both denominators. Factor everything you can. In this case, I could take 5 out. So I get y squared minus 25. But then the y squared minus 25 can be factored further to y plus 5, y minus 5. And over here, your greatest common factor is a 3. Take 3 out, you get y plus 5. Alright, so here's what we have right here. Your least common denominator, it has to be what? 5 times 3 is 15. So between the 5 and the 3, the least common multiple is 15. And then you have a y plus 5 and a y plus 5, so you're good there. You're missing a y minus 5 over here. So look at the red, that's what I have to multiply the top and bottom by on each side, and make sure you understand why.
But I thought the least common multiple between them was 15.
The least common multiple of both denominators is 15, you're correct.
Oh, yeah.
So I'm missing 3 here, I need to multiply top and bottom by 3. It's 15, y plus 5, y minus 5 is your least common denominator. So out of what I just said, you're missing the 3 here, you're missing a 5 and a y minus 5 here. Okay? So after I multiply the top and the bottom by those numbers, this is what I end up with. In the numerator, right here, I end up with 21y minus 20y. You see that? And then plus, because you have minus and a minus, 4 times 5 times 5 is 100.
How'd you get the 4 times 5 times 5?
Well, you're multiplying this number by this number, which is 20, but then you got to distribute that here. Or you can distribute first, then multiply. Either way, you'll get 100. Okay? Then I can combine these two to get what? 1y. So your answer is y plus 100 divided by your least common denominator, which is 15y plus 5, y minus 5.
Did you multiply the 3 by the first fraction because you were trying to get 15?
I needed 15, correct. Okay, can I change that?
Go ahead.
All right, and the last example is a complex fraction. A complex fraction is when you have fractions within fractions. So right there in black is the original problem. You have 1 over x plus 3 over 5 over y plus 4. You need to simplify that. And the way you simplify it is by multiplying the entire problem by the least common denominator of all four denominators. You have four denominators, right? You have x, what do you have here? 1, y, 1. So what's your least common denominator?
1.
xy. So I multiply the whole problem by xy. Or if it makes you feel better, you can put xy over 1. So you can see how I get the next step. Okay? So I multiply this first fraction by xy. What happens when you multiply 1 over x by xy? What happens to the x's?
It's up.
They divide out and you're left with y. Then I multiply 3 times xy, I get 3xy. What happens to the y's here when you multiply by xy?
It's up.
They divide out, you're left with 5x. Okay? And then 4xy, and that's as far as you can go.
You can't cancel out the
Yeah,
xy's
you
and
can
things.
cancel that.
No, you cannot divide anything out, and some of y'all did that yesterday. You cannot divide anything out that's being added or subtracted to another term. Okay? Now, if you wanted to, what could I factor out of the numerator? A y. What could I factor out of the denominator? An x, but it's not going to do you any good in this case. You might want to start thinking about it, because at some point it will do you some good, because you'll be able to divide them out.